Hello everyone, welcome back to my YouTube channel Astitva Study Point, and today we will start lecture 2nd of Electrostatics series. It is represented by me, Arvind Patel. So here you have the concept of electric field. Now what is the mean of this electric field? So the space surrounding an electric field, electric charge small q, in which another charge q naught experience a electrostatic force of attraction or repulsion, is called the electric field of the charge small q. This electrostatic force is that one which we have completed in the last lecture. Means this force we can find out by using the Coulomb's law of electrostatics. So now we will understand what is the actual meaning of this electric field. Let me go on a blank sheet. So here you will see, if you have this capital Q charge, if you have, and if you will put another charge Q naught at this point, now this capital Q charge will apply force on this small Q naught charge, and this one is our positive charge, so this capital Q naught will repel this small Q naught charge. Okay, now what will happen if I will put this small Q naught charge at this point? So it will apply force on it. So it may be apply. Why? Because force is inversely proportional to the square of the distance between them. So if the distance between them will be small, then force will be greatest. Okay, and if the distance between them will be more, then force between them will be less. So as much as we will move away from this positive Q charge, the force will decrease, and there will be a point at which there will be no force due to this positive Q charge. Let us suppose if we are here, so this one is the very far point. Okay, so this positive charge is not applying any force on this small Q naught charge. Why? Because it is very far. So this space, in this space if you will put the charge, so this charge will experience some force due to this capital Q naught, due to this capital Q. But if you will put this small Q naught charge outside this space, so it will not experience any force. So now we can say at this point outside the space there will be force F is equals to 0. But if you will put the charge anywhere inside this space, so this Q naught will experience some force, and force can be given by this formula F is equals to Q naught into E. Okay, so here this E is the electric field intensity. Okay, we will see this electric field intensity in our next slide. But here you can find out this formula, means force F is equals to Q naught E. Now I hope you are getting what is meant by this electric field. So electric field is the space surrounding this positive Q charge in which another charge if you will put, so this another charge, this one will experience some force. Okay, and this capital Q charge is known as the source charge. Why? Because there will be field due to this capital Q charge. That is what is known as the source charge, and this Q naught is known as the test charge. Okay, so why it is known as a test charge? So listen, this small Q naught charge is used for the testing of the electric field. How we will test the electric field? Listen, if you have this capital Q charge, now I want to find out at this point there is electric field present or not. So I will put this Q naught over here, and if this Q naught will experience some force, so we will say there is electric field present. But if it will not experience any force, then we will say there is no. This diagram, so in this diagram you can see this capital Q charge, this one is our source charge, it is our test charge which is used for the testing, And if you will put this small q naught charge outside the field, you can see this space is known as the electric field. Okay, and if you will put this small q naught outside this space, so this one is not experiencing any type of force, and this point which is outside the electric field is known as the infinity. Okay, and here you can see the definition of infinite point, and this E is known as the electric field intensity. So now in our next slide we will see what is meant by this electric field intensity. So here you can see the definition of electric field intensity. So this electric field intensity, what is meant by this? Listen, the intensity of electric field due to charge capital Q at a point in space may be defined as the force experienced by a unit positive charge. Unit positive charge which we have small q naught. Okay, so small q naught is also known as the unit positive charge, called the test charge also, supposed to be placed at that point. So what is meant by this electric field intensity? Intensity means the strength of electric field. So we have seen this capital Q charge has some space in which it will exert the force on another charge, but this capital Q naught charge will not exert the force equally. Suppose if you will put this small q naught charge at this point, so it will exert more force. If you will put this small q naught at this point, it will apply less force on it. Why? Because the distance is more. If you will put this outside this space, so it will not exert any force. So here you can see the force acting on the charge is not equal. Okay, it is not identical at every point. Then it will be electric field will be equals to force per unit charge, means electric field intensity means the strength of the field at that point. Now electric field intensity, remember this one, it is a vector quantity, means our direction will associate with this one, and dimensional formula you will note it down over here, MLT Q inverse A inverse. Okay, and unit will be there, two units will be there, Newton per coulomb and volt per meter. So Newton per coulomb you can see from here, E is equals to F upon Q. So for force you have unit Newton, and for charge you have coulomb, and this another unit volt per meter we will see later. Okay, next if I want to find out the electric field intensity, okay, or the field strength, if you want to find out, then how we can find out? So there are some steps to find the electric field intensity. So what we will do, place a positive unit charge q naught at that point at which we want to find out the field intensity. So what we will do, if we have this space and this one is our positive q charge at this point, if I want to find out the field strength, then I will put this q naught charge at this point. Okay, now we will use this formula, E is equals to F upon Q naught, and by using this formula we can find out the electric field strength. So now let me suppose here we have this positive Q charge, and from this positive Q charge there is a point P at which we want to find out the electric field intensity. So what we will do, we have seen the steps, we will put up positive q naught charge at this point. Now what we will do, so we will find out the formula, we will find out the force on this positive q naught charge. So force we can find out by using Coulomb's law, and according to Coulomb's law there will be a constant k, first charge q and second charge q naught upon distance between them small r. So force will be there, F is equals to k q naught upon r square. Now how we will find out the electric field intensity? E is equals to F upon q naught. So here you will divide this force by q naught and you will get the value of electric field intensity, k q upon r square. Now remember this electric field intensity. So what we have, k q upon r square. And here this k, last time we have seen this one, k is equals to 1 upon 4 pi epsilon naught. So finally we have the formula for electric field intensity due to this charge q. What we have, E is equals to 1 upon 4 pi epsilon naught q upon r square. So here you can see this derivation. So derivation for this electric field intensity you can see over here. Here you have this plus q charge, okay, q naught charge is the test charge. Here first we will calculate the formula. You can note down this derivation. Field intensity. So what will be the direction? Here you can find out the value of electric field intensity by using this formula. We have solved this derivation. Now if the charge is positive charge, okay, then direction will be away from the source charge, and if the charge is negative then it will be towards the source charge. Okay, so here you can see for electric field, last time we have seen the superposition principle for the Coulomb's force, but now we will discuss about the superposition principle of electric field. So it is also similar as we have completed in the last lecture for the force. So it is like that. Okay. So here you have, if there are small n charges q1, q2, q3, qn, lots of charges are there, means if the number of charges are there, suppose if you have this q1, another charge you have q2, third charge you have q3, and last charge you have qn. Suppose you want to find out the electric field intensity at this point P due to these all charges. So there are multiple charges. So what you will do, you will find out the electric field intensity at this point P due to this q1. Then you will find out the electric field intensity due to this q2 on this point P. Then you will find out electric field intensity due to this q3, and finally at last you will find out the electric field intensity due to this qn. And let us suppose the electric field intensity due to this one is E1, due to another charge q2 is E2, and due to this third charge there is electric field E3, and due to the last nth charge there is electric field En. So we have the formula for electric field intensity. E is equals to k q upon r square. So by using this formula we can find out E1, E2, E3 and En. After finding these values, you have E1 is equals to 1 upon 4 pi epsilon naught q1 upon r1 square. Let us suppose the distance of q1 from point P is r1. Similarly, E2 is equals to 1 upon 4 pi epsilon naught q upon r2 square. Here we are finding the electric field due to this q2, so here we will write q2, and at last you will find out the electric field intensity due to nth charge, and it will be 1 upon 4 pi epsilon naught qn upon rn square. Okay, let us suppose the distance of nth charge from point P is rn. So finally we have these values. Okay, now we will add them. Okay, means we will perform a vector sum on these values to find out the net electric field. So net electric field will be there, E is equals to, here we are finding net. So net electric field will be equals to E is equals to E1 plus E2 plus E3 up to En. Okay, and we are performing a vector sum, so we will put the arrow sign also, because we will take this electric field as a vector quantity. Okay, and we will perform the vector sum. Vector sum means direction we will also include in this addition. So here we will perform this vector sum, and finally electric field will be there 1 upon 4 pi epsilon naught. This one will be the common term. So here you have q1 upon r1 square plus q2 upon r2 square up to Qn upon Rn square. Okay, so this one will be the actual value for the net electric field due to multiple charges. Okay, and this equation can be written like this: E vector is equals to 1 upon 4 pi epsilon naught summation Qi upon Ri square. And it is a vector sum, so direction will also be there, and direction we will represent by this unit vector r cap. So finally we will get this formula for the net electric field: 1 upon 4 pi epsilon naught Qi upon Ri square r cap. And here you have this I is equals to from 1 to n, so you will put this limit also, I is equals to 1 to n. So finally you can note down this derivation over here. You can see if you have this small charge Q1, Q2, Q3 up to Qn charges, there will be the net electric field and it will be the vector sum equal to the vector sum. So how you will perform the vector sum? You will add all the values and you can write this one like this. So you can note this derivation by pausing this video. Okay, now next one, subscribe this channel to get the more videos. Thank you.